Hello, good morning friends. Welcome back to your favorite channel Code One Digest. Today in this tutorial, I'm going to show you how to create microservices in Nestjs Framework, how to run it in a Docker container, and how to connect our microservices to a Mongo DB running in another Docker container. Yes friend, so in this tutorial, we will be running our microservices in one container and we will be running MongoDB in another container, and our microservice container will interact with our database container. I'll show you this step by step. How can you create this application, this project from scratch? So stay tuned and watch this tutorial till end. It is going to be very exciting. If you want to learn Docker, if you want to learn Nestjs framework, if you want to learn MongoDB, if you want to learn Node.js, if you want to learn JavaScript, then this is a tutorial for you. This is all-in-one tutorial for you where you will be learning multiple concepts. Right friends? So stay tuned and watch this tutorial till end. Friends, so here is the agenda of this tutorial. So I'll brief you about Nestjs MongoDB project. I'll explain you this with an architecture diagram. What are we trying to achieve in this tutorial? Then I'll show you how can you download and run the MongoDB image in a Docker container. Then I'll show you how can you create and set up Nestjs project in your local. We'll be installing all the dependencies for the Nestjs framework. Then I'll show you the coding of controller, service, repository layer, entity classes and module classes in our Nestjs framework. Once this is done, then I'll show you how can you create the Dockerfile and create the Docker image for your Nestjs application. Once that is done, then I'll show you how can you run Nestjs microservice image into a Docker container. Finally, we'll be testing our Nestjs microservices API and validate if our application is able to connect to MongoDB database running in another container. Right friends, so stay tuned and watch this tutorial till end. It is going to be very exciting and very informative tutorial today. Friends, so here is a prerequisite for this tutorial. You should have a Node.js version 16 and above. I am using version 18.14.2. Then you should have Nestjs 10.2.1 and above, npm 9.5.0, VSCode editor. I am using Docker 20.10.14. I am also using Postman API testing tool to test my microservices. MongoDB community version 5.0.0 and MongoDB Compass 1.35.0. Right friends? So if you see this diagram, this is my localhost machine, okay, and in this localhost machine I'll be running two Docker containers. Okay, one is for database. This is MongoDB container where my database will be running, and second one is my microservice container where Nestjs microservice application will be running, and these are their internal IP addresses of Docker containers: 172.17.0.2 and 0.3. Right friends, so now in this container MongoDB image is coming from our Docker Hub repository, that is from internet. So we will be downloading MongoDB image from Docker Hub repository and then we'll be running it here. Once the MongoDB is up and running in our Docker container, then we'll find out what is the IP address of this container, because my microservice which is running into another container has to connect to this database. Now the connection between these two containers is via bridge network. So Docker having a bridge network between these containers, and it allows us to connect the application running into those containers. So using the IP address of MongoDB container, this microservice will be able to connect to this database. The application running in microservice container will access the database using the container IP and the port. Right, so this is between the containers. But let's say we want to see the content of this database by connecting our MongoDB compass. So at that time, we have to use the port mapping. At the time of starting this container, we have to tell what is the port mapping, right? So we will be doing a port mapping of 27017 of container port to 27018 of our localhost port. So when I'm connecting from my MongoDB compass in localhost machine, that time my URL would be look like localhost 27018, and that will redirect the request to container 27017, and that's how I'll be able to connect to database, right? So this interface is sorted through Beige network, this interface is sorted through port mapping, and this is coming anyways internal to our Docker. When we say Docker pull image, so it will pull the image from internet and keep it in our local repository, local Docker repository. Fine. One database container is up and running, then we'll prepare for microservice container. In this, first we'll be preparing a Dockerfile. Then second, we will be creating a Docker image using the Dockerfile. Then we will start an application using the Docker image. Hence, it will run into a Docker container. So once that is running into a Docker container, it will connect to this database. Once the application is up and running, then we'll be hitting the API from our local host on port 3000. So here also we will be doing a port mapping because our microservice is running on port 3000, hence we'll be mapping the container port 3000 to our host port, localhost port 3000. Hence I'll be accessing the APIs here like localhost 3000. Right friends? So this is the architecture. So stay tuned and watch this tutorial till end. It is going to be very exciting. Right friends? Friends, in the previous tutorial, I covered how can you create Nestjs application using Postgres database. If you want to create enterprise level application in Nestjs Framework having a Postgres DB as your backend, then this is a tutorial for you. We'll download the MongoDB image from our Docker Hub repository. So how can you do that? So open Google and search for Docker Hub MongoDB. So it will open a MongoDB official image page in Docker Hub repository. This is the official page of MongoDB and there are multiple tags available here. That means there are multiple Docker image available here. This is the latest version of the Docker image and this is for platform Windows and Linux both. You can take the latest version if you want to by using docker pull mongo latest. You have to run this command in your local machine to pull this image into your local Docker repository. So it will pull that Docker image. You can go for any of the version that you want. I'm using 6.0.0 and I have already downloaded using this command. For every image, you will have a command to pull it. Once you pull this Docker image into your local, it will look like this, Docker images. So do you see this MongoDB? So that MongoDB has come and I have downloaded 6.0.0 few months ago and I'm using the same. Once you pull that MongoDB image, it will listed in your image list here. Right friends? Once that is done, then you can come to overview page. It will guide you how can you start that image. So there are instructions given how to use this image. To start MongoDB, you have to use this command docker run manage name and manage the Mongo tag. So using this command, you have to start your Docker image. But I'll give you another flavor of this command, very similar to this, by adding a -p port mapping option. So let me show you that command, what I am using. Docker run manage name Mongo 606. I'm giving this name. And as I said, I'm using additional parameter -p for the port mapping. I am mapping 27017 port of container to 27018 of my local machine. That means when I want to access the database from my local machine, then I'll be using 27018. When the request goes on this port of my local machine, it will route that request to the 27017 port of Docker container. Got it? So this port mapping is important because we are going to use it, and I'll show you in coming demo. Right friends? So this you have to remember, and manage D is to deattach the screen, and this is a tag Mongo colon 6.0.6. So this is a command. Instead of 6.0.6 you have to use latest or the preferred tag of your MongoDB, but rest of the command will remain the same for you. Okay friends, let me start my MongoDB first. Docker images. So this is the image I have. Docker ps. So no image running as of now. Docker ps -a to see all my inactive containers, that is none of the container is running. But if you see here, I have a container Mongo 606. So what I can do is I have to just start this container. For you, the command to start your MongoDB is this, but for me, as I already have a container created, then I'll be just running this container. I'll say docker start this container ID. If I'll say docker ps, so it will show me the container running image Mongo 606, and that is a port mapping done here, right? 27018 of localhost pointing to the 27017 of Docker container. This is a container name. Okay friends, so our MongoDB now up and running. Now what I'll do is, let me try connecting this database via MongoDB Compass. So I open my MongoDB Compass now. So if you see this localhost 27018, right? So here it is localhost 27018, and when the request goes on 27018, it will pass that request to the container 27017. Let me try connecting it. Yes, so it is able to connect to MongoDB running into a Docker container. So if you see MongoDB 606 community version, it is connected to the database. We are successfully connected to our MongoDB that is running in our Docker container. Got it friends? Okay friends, so now without wasting any more time, let's create the Nestjs MongoDB project. Go to a directory where you want to create a project, open a command prompt at that location. Okay friends, so very first thing that we have to do is to install the Nest CLI. So here is the command to install Nest CLI so that it understands Nest command. We are going to use Nest command after this to create project, to create our controller, to create our services and so on. So very first thing that you have to do is to install the Nest CLI. If you already have Nest CLI, then you can skip this step. When Nest CLI is installed, then we are ready to create our project. So here is the command to create a Nestjs project. The command is nest new Nestjs Microservices MongoDB. So this is the name of the project that I am giving. You can give any name as per your requirement. So nest new name of the project and say enter. So it will create all the libraries, all the required files for me. So it's asking me what is the package manager that I want to use. So I would be using npm. Yes, it will take a couple of minutes to download and get ready your project. Okay friends, Nestjs project is created, project directory is created. Go inside that project directory. Yes, so you would see files are created for you, package.json file with all the required dependencies, and it has a source folder where we have a boilerplate code available for us, like default controller, default service and default module classes are, and main.ts file is available here. So we'll load this into VSCode and we'll see that. Okay friends, so that project I have loaded in my VSCode editor now. So this is my package.json file having this default dependencies. As you create Nestjs project, so this Nestjs common, Nestjs core, Nestjs platform express, and reflect metadata RxJS. These 5 dependencies will come by default to you always. It has some boilerplate code available inside the source folder, that is our main.ts file where the application is start. Here we are bootstrapping our application. That means here we are starting our application using Nest factory. So this is creating an instance of an app, and then basic controller, service and module classes. Right friends? So now what I'll do is, as we are creating a Mongo DB project, so we have to install Mongoose as a module, right? We need Mongoose. It's an object relation mapping tool. It's kind of a ORM which is required to interact with our database. We will need ORM as a bridge between our application and database. Okay friends, so I'll install the Mongoose. Mongoose is a well-known object relation mapping tool that interacts with MongoDB and your application. Okay friends, so now I'll install Mongoose module. So here is the command to install Mongoose module is npm install save Nestjs Mongoose, right? So it will install and get added into our dependency list. All the required files will get downloaded into our load module folder. Let me install this. Once we install this, then only we'll have those MongoDB related drivers and classes available, Mongoose module, MongoDB module available for us to import in our application module. I'll show you in a while. Okay friends, so this is added. Now we can validate in our package.json. Mongoose is added here. We'll use this Mongoose to connect to our database and to create object relation mapping. So inside the source folder, create a folder schema and then create a file student.schema.ts, right? So this is the file. It is our domain object. So in this tutorial I am going to create a student database where we'll be storing the student details. So this is going to be our student schema file. So this is how our student schema look like. Student is an object having name as a string, roll number as a number, class as a number, gender as a string and marks as a number. And here we are using schema decorator. So this is coming from our Mongoose dependency, right? So schema and property, these two decorators are part of our Mongoose module. And then finally we are exporting our student schema. This hydrated document is just a way to create MongoDB document from our raw JavaScript object. Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming and coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you. It's time for us to create controller and service class. I'll be creating the student controller and student service using a CLI command, Nest CLI command. So here is the command Nest generate service student. So it will create me student service.ts file. Yes, so it is created and now I'll generate a controller class, that is student controller. So command is Nest generate controller student. Press enter. So it will generate a student.controller.ts file. Right, it is done. So let us see now in VSCode. So you see this student directory is created automatically. Inside student directory you have a controller and you have a service classes. And if we see our app module, so inside this app module, controller array, student controller is automatically got added, and in provider array, student service is automatically got added because we created it through CLI. So CLI is intelligent enough to do all this homework for you, right friends? So now what we'll do is we'll write a code inside our service class to interact with our database, to insert data and to retrieve data from MongoDB. Okay friends, so before we write code into our student service, we would require a DTO class. So let's write a DTO class first. So inside a source, you create a folder DTO, and inside DTO, you will be writing a class. Create student DTO.ts file. So before we write code into our DTO, we have to install our class validator. So go to command prompt and install class validator dependency, npm install class validator, save. It will install a class validator because we will use this class validator in our DTO. It will validate the input parameter as per the properties defined, right, for our DTO. Okay, this is done. Let's go back to the code. Now we are good to write our DTO class. Okay friends, so here is the code for our DTO. Okay, so this is my create student DTO class, and here I have property name as a string, then roll number as a number, then class as a number, gender as a string, and marks as a number. You would see that we are writing these decorators is a string, max length, so all these things are coming from our class validator. This makes it easier to define and to validate the provided input. So these are very useful thing. This DTO is created. We are good to go and create methods in our service class. Okay friends, so here is the service layer class, business class. So very first thing that we have is a constructor. In constructor, using inject model decorator, I am creating a model of our student. So the student is our model here, domain object. Now the very first method that I am writing is here is create student. This is to insert student into our Mongo DB, right? So create student, taking create student DTO as the input, and in return it is returning a object of student. So this is my student model, and model is a class coming from Mongoose, and it is of type student. Student is of type schema. Student model will give me instance of student, and that will save using save function, save method in our MongoDB. Right friend, this is clear. Now next method here is to get all the students available in database. So here we are returning array of students. Okay, we are calling find method on student model, and we are getting the student data, and this student data nothing but is a array of student. So these are two very simple methods that we have written in service class. Now it's time for us to write a controller so that we can call these service methods for a given API. So now in this controller class we'll be writing few routes so that we can create student and we can retrieve all the students. Okay friends, so here is my controller code. The very first line that we are doing here in the controller is we are injecting our service student service class here through a constructor injection. Okay, as our service class is injectable, we can use that in our controller. Once this is done, then we have a post mapping, create student method. Here we have two parameters, one is response object and second is the incoming request input object of type body. So that body is coming into our create student DTO. It is of type create student DTO. This is the object, and then on next line I am calling this dot student service dot create student by passing create student DTO, right? So this DTO object I am passing here inside this create student function of my service class, and then it is giving me a object of student as a response. Finally, I am creating a response status in my response object. The response.set status created with the message student has been created successfully, and that object student object. If there is any error, then I am handling through our try and catch. Inside error, I am again preparing a response with bad request status message error creating the student. This is very simple post method, no fancy thing. Now next method is our get method to fetch all the students from repository. It has one response parameter. We'll use that to send response back to our customer. Now very first line what we are doing is we are calling our student service dot get all students. It is coming as a student data. This is an array of student. Now I am preparing a response, that is response dot status okay, that is 200.json. Message is all student data found successfully, and this is the object. This is the array of student. If there is any error, so I am preparing a response message with status error and that error message. Right friends, very simple. Two endpoints, one is post and one is get. This is my controller class. We are ready with controller, we are ready with service class, we are ready with our schema, we are ready with our DTO. I think we are ready to run our application. So now what we'll do is I'll run this application and then we'll test our APIs. Okay friends, so before we jump to our Docker file, I have made some changes in the application so that we can read the database configuration from the environment variable. As we are going to run this microservices into a Docker container, hence we should be able to give the IP address, port, database name from our environment variable. We don't know what will be the IP address of our Mongo DB container. Hence, we have to read that at runtime from an environment variable. So, to achieve that, the very first thing I have done is I have created this configuration.ts in a config directory. So, in this configuration.ts, I have defined a database. I'm exporting database as an object with URL as an attribute, and here I am reading the MongoDB URL from environment variable like process.env.database URL. Actually reads the database URL from our environment variable. Database underscore URL is my environment variable. So in this environment variable, we will provide the MongoDB URL. So when I run it in my local, I provide this environment variable in the .env file like this. Got it? So when I am running this MongoDB 127.0.0.1 and this is my database name. So this is the URL that we have to give as an environment variable, and the variable name is database URL. So remember this, we are reading this from environment variable. Once it is available in our configuration, then we'll use this configuration in our app module. Because in app module, we are initializing our Mongoose module. Mongoose is our object relation mapping. It is a persistence layer like an Hibernate which helps us in connecting to our MongoDB. So this is a module, Mongoose module. So before Mongoose module, we are initializing a config module, and config module is coming from Nestjs config. So you see the config module and config service we have imported. Now we are saying config module for root and asking it to load the configuration file, configuration.ts. So this configuration.ts, it is getting loaded here. And in what is there in configuration.ts? In configuration.ts, we are defining this database object with URL as a attribute. So once this config module is initialized, this configuration.ts is loaded, then we are initializing our Mongoose module by providing the config module in it, and we are using config service here. Config service will give us the access to this database.url. So same thing I have written here. I am starting here Mongoose module option, and here in URL I am providing config service.get database.url, and database.url is coming from here, database.url. In this URL, value is coming from environment variable. So finally that database URL will come and sit here. Once this is resolved, then Mongoose module will be able to connect our application to the database based on the database URL. Got it? So at the time of starting our application, all this module will get loaded one by one, and it will try to connect to database based on the URL that will pass from environment variable. Now, as we have made this configurable, so at the time of starting our application, we have to pass database URL as an environment variable. So remember this, I'll cover that. I'll show you that how can we do it. Now, let us see a Docker file now. So this is my Docker file. What I am saying here is from node 18. So it will download node version 18. This is my working directory inside the container virtual machine /user/src/app. Copying the package.json from current directory to the directory, running npm install so that it can download all the dependencies and create node module directory over there. Then copying all the content from here to the inside the container, exposing the port 3000, right? Because our application will be running on port 3000. And then this is a command to start my application, npm start, right? When we run in our local, we'll say npm run start, but when we give in Dockerfile, we give like this, npm start, right friends? So now next step is to create the Docker image for our application. Let me do that. Okay friends, so now as we have prepared our Docker file, let me show you how can we create the Docker image for our Nestjs application. So here is a command that we'll use to create the Docker image for our application. Docker build -t is for tag, and this is my tag name that I'm giving to my image, code1digest / nestjs -mongodb -mongoose -project, and dot is because we are running this command from the root directory of our project where Dockerfile exists, right friends? So we are telling Docker that your Docker file is available in this current directory. But if you are running this command from some other location, then instead of dot, you have to give the absolute path of your Docker file, right friends? So let me copy this command and then we'll build the image. Let me go to console and let's see all the images available to us. So these are the images that is available from the past. I don't have any Nestjs MongoDB image here. I'll paste this command here and say enter, right? So it is downloading all the dependencies, all the modules. It will take few minutes. Yeah, looks like it is done. Now let me see Docker images. So it says the image is created and this is the image ID, this is the latest tag, and this is the repository, right? And it is of size 1.49 GB. So now what I'll do is I'll use this image to start our application in Docker container. So we already have our Mongo DB container running. Now what I'll do is I'll run my Nestjs application in another Docker container, what we have seen in the architecture diagram, right friends? We would need the IP address of our MongoDB container so that we can use that IP to form the database URL, and we will give the database URL as an environment variable to our Nestjs microservice application, right? So let me find out the IP address of our MongoDB Docker container. How can we do that? Let me show you that. So Docker PS shows us which container, what container is running. Now there is a command docker inspect to see the detailed information of any container. So you have to write docker inspect and give the container ID. Now this will give you hell lot of information, right? How will you find where is the IP address? So we will use the grep command, grep IP address. Do you see the IP address have been grabbed from all that information, and this is the IP address that we have to use, 172.17.0.2. This is the IP address of our Mongo DB container, right? Now I'll use this IP address to form the MongoDB URL, and then we will use that URL in our Nestjs Microservice Docker run command. Okay, we'll use this URL as an environment variable in our Nestjs application command. Okay, let me show you that. So here is the command to start my Nestjs application, Docker run, right? And -e is for environment variable. -e means this is my environment variable, and environment variable name is database URL. If you remember, we are using process.env.database URL. That means we are reading database URL from environment variable. Hence, we are passing database URL environment variable in our Docker run command. And what is the value of this variable? MongoDB : IP address. So this is the IP address of our MongoDB container, and this is the port of MongoDB database running in that container. So when container interacts with another container, then we have to use the container port, not the localhost port. So what is the container port for my database? It is 27017. But what is the localhost port for this database? 27018, right? If you see this Docker PS, so this is the container port of database 27017, and this is localhost port of this database 27018. So when container interacts with the container, that time we have to use container port, right? Hence we have to use 27017 here in this command, and then slash, this is my database name, student DB, right? So this is my environment variable, the MongoDB URL. Then I have -p for port mapping. Here also I am mapping the 3000 port of my container to localhost port 3000, right? Because my microservices are running on port 3000, and I'll be accessing the application on 3000 from my localhost. Hence this port mapping is done, and this is the name of my image, right? So let me copy this. Let me go to the console, Docker images. So this is the image, Code1 Digest, Nestjs, MongoDB, Mongoose project. And here is the command, Docker run -e for environment variable, database URL is the environment variable, and the URL of MongoDB, -p is for port mapping, and the name of my image. Say enter. Now it will try to connect the MongoDB container for database connectivity, right? So here it says our application is successfully started and is able to connect to the database. Now what I'll do is, let's hit some of the endpoints of our microservices to see if the application is working fine. We are able to fetch and insert data into our database. Okay friends, this is my postman. So very first endpoint that I have here is save student, and then I have another endpoint to get all the students. So let's see the save student endpoint first. So here I have localhost 3000 student as an endpoint of type post, and the body that I am passing here is name, roll number, class, gender, and marks. This is exactly same information what is defined here in our schema file. So where is the schema file? This is our student schema file, right? Name of the student, roll number of the student, class, gender and marks. Same information we are passing in this body. Okay, so let me change the name here. Let's say Pawan, and let me call this. Yes, so I got 201 created response. So this is the response of my API. This is a unique identifier, name Pawan, roll number, class 5th, gender male and marks 85. Right friends? So this is one endpoint, that means, so this is insert endpoint. That means we are able to insert the data into our Mongo DB. Right friends? Now the second endpoint here is to get all the students we have in our database. So it is of type get, HTTP localhost 3000 student. It will fetch all the students available in my repository. Let me hit this. Yes, so 200 OK response, and I got two students here. First is Ravi and second is Pawan. That means our get and post endpoints are working absolutely fine. We can also validate the data using our MongoDB. Right friends? So let me open the MongoDB compass. Let me connect to database using 27018 port, and this is my student DB, students collection, and here I have two records, Ravi and Pawan. Right friends? That means our APIs are working fine, our application is working absolutely fine in Docker container and able to connect to a MongoDB running into another Docker container. Right friends? So we are able to establish the connection from our microservices running in one Docker container to a database running into another Docker container. This is what we wanted to achieve in this tutorial. Right friends? So if you like this video, give it a thumbs up, and if you are new to the channel, so do subscribe to my channel to grow Code1 Digest family. Thank you. You need not to worry about the code. The code and all the commands are available in my GitHub repository, that is Code1 Digest, and this is a project Nestjs complete tutorial. You can clone this repository, download all the code. The project that I have explained you today is also available here, like Nestjs MongoDB project. Right? So all the code, all the commands are available here for you. Just download this repository and start using it. So if you like this video, give it a thumbs up, and if you are new to the channel, so do subscribe to my channel to grow Code1 Digest family. I have also created complete playlist for Nestjs tutorial where you will find the videos on the multiple concepts of Nestjs framework. So go and watch this playlist. It has all the concepts of Nestjs framework. Go and watch this playlist. It is going to be very exciting and informative playlist for you.